I'm going to show you how to write a program for the TI-84 calculator that will calculate the Wilson score interval, which is a more accurate confidence interval for p hat when the sample size is small. We're going to start by pressing the program button and arrowing over to the keyword new and hit enter. The alpha lock sign is there, so we're just going to type letters for Wilson and hit enter. So we're creating a program called Wilson. First thing we want our program to do is clear whatever writing is already on the screen. So we're going to press second and the program button and hit enter for clear draw. And then we're going to display the name of our program on the screen. Program button, arrow over to IO. The third item on the list is display. And we want to turn on alpha lock, second alpha. And then we need quotes. And then we're just going to type Wilson. The space is down here, alpha 0, and then the word score, and then another space, and then the word interval. And then end quote. So our program is going to display the words Wilson score interval. Oh, maybe I should add the N. Insert alpha N. Okay. Then we're going to ask the user to enter a value for X. So that's program IO and the command prompt, and then the letter X, which will be the numerator of the fraction that creates the sample proportion p hat. And then we're going to ask them again, program IO prompt. We're going to ask them for N, which is our sample size. I wish we could do lowercase n, but we're just going to go with n like that. And then we're going to ask them for a value for C, so program IO prompt again, a value for C, which is going to be our confidence level. And then our program is going to go to work. First of all, we want our program to figure out the appropriate value of Z. So we're going to do second var's inverse norm, and we're going to do inverse norm of 1 minus whatever they entered for C, close parentheses, divided by 2. Mean 0, standard deviation 1. So we want inverse norm of 1 minus C over 2, 0 and 1. And we're going to store that into variable Z, alpha Z, and hit enter. And that usually results in a negative value of Z. So now I'm going to press the math button, the number menu, and absolute value of Z. And we're going to store that into Z. Okay, then we're going to create our sample proportion. So we're going to do X divided by N, so alpha N, and then store that into P, so alpha P. So now we have everything we need to throw into this formula. We just have to enter this really ugly formula. And so that we only have, I'm going to use a little bit of a trick so that we only have to enter this once. So parentheses, alpha P, which is actually our p hat, and then this first adjustment that we see in the Wilson score interval, which is plus Z squared divided by parentheses 2n. So P plus Z squared over 2n. And then normally after that, we have a plus or minus sign. And here's how we accomplish the plus or minus sign. Second parenthesis gives us a brace, and we're going to do a -1 and a comma and a +1 and then an end brace. And that's plus or minus Z. and then a really long, ugly radical. So what's in the radical is what's traditionally in the radical in a confidence interval, which is p times 1 minus p, and then close parentheses divided by n, p times 1 minus p over n. That's what's traditionally in the radical for a regular confidence interval for a proportion. And then we have this adjustment factor plus z squared divided by parentheses 4n squared. So this is close parentheses on that radical, then the first is close parentheses on that denominator. The second one is close parentheses on the radical. And then we also have close parentheses on the entire numerator. And then this whole expression divided by, we have an adjustment factor in the denominator, which is 1 plus z squared over n. 1 plus z squared over n, close parentheses, and then we're going to store that in, because this is automatically going to result in two answers with the negative one and with the positive one, so the plus or minus. So we're going to store this answer in list 1, which is not really great programming practice because that means it's going to obliterate whatever was previously in list 1. And then I'm going to round that off to, I would say, 4 or 5 decimal places. So I'm going to do math number round. And what am I going to round off? I'm going to round off everything that's in list 1, comma, to 4 decimal places. Whatever's in list 1, I'm going to round off to 4 decimal places, and then I'm going to store that back into list 1. And then as the output for my program, I'm going to do program IO display list 1. Okay, now we have a problem on the homework that requires the Wilson interval. So let's just see if we can use our program to get the correct answer. This problem from the homework, at least with my numbers, says, in a test of one type of firefighter's mask, 12 of the 60 masks had the lenses pop out at 250 degrees. Construct a 90% confidence interval for the proportion of this type whose lens would pop out at 250 degrees. So let's run our program. Program Wilson, execute, bam. It's asking for x. Well, our proportion is going to be 12 out of 60, so the x is 12, and the n is 60, and then the confidence level is 90%, so we're going to enter that as 0.90 and let the calculator do its work. Bam! 1289 to 297. 1289 to 297. How about that? So that little program perfectly constructs the Wilson score interval, 1289 to 297. Notice that if we did the traditional confidence interval for a proportion, the 1 prop z int on the calculator, and we do our 12 out of 60 with 90% confidence, we get 115 to 285. 115 to 285. So just to highlight the difference between the traditional confidence interval for a proportion and the Wilson score interval.